All right, everybody can hear me? Okie dokie.
Yep, we can hear you, Lippman.
What time does this class
We
end?
hear you.
This class ends at 12:50. All right, so let's start off with, well, let's just go to the slides. Okay. Now, I think most of you had me in class last semester, but just in case, we do have a couple of new people, I believe. Let me throw some stuff up here. So if you, we have a Slack channel. So if you go to cuwcs.slack.com and you sign in, you can create an account with your cuw.edu email address, and then you'll be able to sign in. That's going to give you a, let's see, share. That'll give you a page kind of like this. And then you can scroll down and there is a channel for CSC250. I'll go ahead and star this so it shows up at the top of my list. So join this channel. I'll make announcements and things like that in here. As those of you who had it last semester know, there's an app for iPhone, Android, Mac, Windows, Linux. So get one of the Slack apps for whatever device you most commonly use and set up notifications for at least the 250 channel. So if I send something or somebody else is posting something related to the class, you will get those notifications. Sometimes I might modify a homework assignment or something like that. So this will be beneficial from that perspective. Again, I also encourage you to start study groups like several of you did last semester. You can do these online with Zoom, or you can do these face-to-face if a bunch of you live on campus. You can also create private Slack channels if you want to have just a group that you can, share code with and things like that, and keep it off the books, I guess. But anyway, you cut it. Once again, I encourage you to work in groups for your assignments because, again, this is programming. It's hard, and putting in the reps is what's required. And sometimes, let me do something here real quick. My last class just finished uploading. So let me make sure it's populated up there. All right, that'll be good. But yeah, in any case, just like last time, I'm not going to look for cheating and stuff on homework assignments. Work in groups, make sure you're learning something. I'll find out on the finals or whatever if in the midterm and the final if you're not, and life will go on. Make sure there's nobody in the waiting room. Okay. So let me share the screen again. All right, questions about the Slack channel? Everybody's good with that? All right, so if I post something on the Slack channel, that's as if it was sent by an email, so you're expected to have seen it. So take that seriously. It's not just this secondary communication option. Then I'll go ahead and put up another link here if you wanted to start downloading while we're cooking here. So website, eclipse.org. I'll go ahead and go there. Let me move the class up here. All right, so once you're at eclipse.org, go to download. And you want to get the Eclipse IDE for your favorite, whatever. So do download. There are different packages. Let's see what happens if I do download packages. Yeah, actually, this might be better. Well, actually, let's just go through the normal one. So download Eclipse installer for your platform. For me, it's Mac OS. I think I already have it on here, but I'll just go through the process so that when we get to it, I can walk everybody through it. So if I clicked on it, it's opening. I think it's going to be easiest if I just share my desktop. All right, so that brings up something that looks like this. I double clicked on that. We'll start the Eclipse installer. All right, so now once you get to this screen, the one you want is the Eclipse IDE for Java developers. This guy up here. And let it go ahead and let it default to all these things. If you do not have the Java Virtual Machine 1.8 or newer, you might have to go and download that. That's probably only something you have to do on Windows, but it will walk you through that if it, you can click on a download link and they'll take you there. But you need to have two things here. You need to tell it where can it find the Java Virtual Machine, which we'll talk about today, and where do you want to install it. So click install. And all these things are free. So just accept the content it's installing. Okay, and then once it's done, click launch, and it will launch the Eclipse IDE. When it first opens, it'll ask you where do you want to keep your workspace. You can just leave it to the default. So this is just going to be where it saves your code. If you use something like Dropbox or something like that, you might choose to change the directory here for it to be somewhere in your Dropbox. I'll actually go ahead and just do that. So I'll go to Browse. I have Dropbox on my machine, and I'll just create a link here that's called Eclipse Workspace. So now I have a folder that's on Dropbox, or if you don't use Dropbox, instead you use like Google Drive or Microsoft, something like that. Someplace that automatically gets backed up, so if you have a corrupt hard drive or something, it doesn't go away. So now it's doing it inside my Dropbox. I'll just say use this as my default, don't ask again. I'll click launch. All right, so then it gets us up to Eclipse here. We're going to just leave it at this for right now. All right, this is equivalent. What we're going to use Eclipse for is the equivalent to what we did with that Thonny Python for Raspbian last semester. So this is our version of that. Again, it's an industry standard tool. Lots and lots and lots of people use Eclipse. So we'll get used to using that. It's also available on Linux. I do still encourage people to still use Linux this semester, but you already had a semester of using it. If you liked it, maybe upgrade to like an Ubuntu or something like that. But you know, that's not going to be an exercise we do this semester. We're going to focus more on some other things, but Eclipse is going to be something we're going to use.
So I know you mentioned something about there being a Java virtual machine to download. Was that automatically download the installer, or do you have to download that separately?
It should automatically download the installer. You can get that at java.sun.com, but I'm pretty sure that
Is it just a default Java? Because I think I have just Java language downloaded.
well, but it needs to make sure it's at least 1.8, which should be, because it's way past that right now. So chances are, if you already have it installed in your machine for something else, it found it.
Got it.
But
yeah, I think it's already found it.
Yeah.
I'll just
Java SE 14.0.2 is the latest one. So, you know, if you download that and, you know, just keep in mind where it put it, you can tell Eclipse to go look for it there, but it probably will find it on its own. All right, so let me get back to the slides here. And I'm going to specifically share just the slides. Okay, so that's our Eclipse. Next, and I did send out an email the other day, but face-to-face classes. Several of you have already done this, but so this class has, I don't know, 30-some people in it. The COVID capacity for our classroom is like 21. So we kind of have two options. I can divide the class in half and say half of you come on Tuesdays, half of you come on Thursdays. Problem with that is that some of you have very strong opinions about face-to-face. Others of you don't care. So I'd rather have the people who really, really, really want to be face-to-face get to be face-to-face every class, and the people who don't really care, maybe they come face-to-face, maybe they don't, depending on the number of people who definitely want to be face-to-face. So with that in mind, if you have not already emailed me, if you have a strong opinion and you'd like to be face-to-face this semester for the Tuesday and Thursday class, just send me an email as soon as possible today so I can get you added to the list. The plan is that we won't have more than 21 people likely that really, really, really want to be face-to-face. So I'll be able to accommodate anybody who wants to be face-to-face. We'll be able to be face-to-face for every class. And then I'll just mention, okay, we have room for an extra 7 people or something like that. And then if you sort of felt strongly about it, you can get added to the list or something. And then if there's problems, we'll just deal with them there. But the preference would be is anybody who wants to be face-to-face can come face-to-face to every class and not have to do the vice versa thing. So that's the plan. Class is going to be delivered the same way regardless. So every single class, I'll start up a Zoom session. I will record that Zoom session. Just make sure I have my recording going. Yeah, I do. So I'll record the session. I'll upload it to YouTube just like last semester. So I guess your options are this: attend face-to-face, attend during class time on Zoom, or if for some reason you have to miss class or whatever, you can watch the video later on in the day from the class. So whatever makes you happy is fine, but do send me this email as soon as possible today if you really want to be face-to-face, so I can ensure that we can accommodate all students who feel they'll be more successful in face-to-face. Well, or try to ensure that. All right, questions about that? It'll be the same product regardless. I'll be doing this exact same thing. I'll be on Zoom during class. I'll have an audience in front of me. I'll have an audience online. I'll record it. So it makes no difference to me. I'm doing the same thing regardless with how many people are in front of me and how many people aren't, and we'll go from there. All right, questions about that? All right. For the face-to-face, and I did link it on the email, and it's also on an announcements thing on the website on Blackboard. There is like an official policy thing for what the uncommon return to campus. I'm sure you've gotten 4,000 emails from school administration about it and stuff. So read through that, make sure you understand what the policies are. I think if you're in the halls or in class, you have to have a mask on. I think there's like no eating in the classroom. I don't know about drinking. I'm guessing no. Maybe you can sneak a straw behind there. I'm not sure. But whatever the policies are, follow those. It is what it is. It's, inconvenience over, I guess, public health. So let's all do our part and hope that it helps and all that stuff. So, but in any case, make sure you follow those rules if you're going to be face-to-face on campus. But in any case, if you want to do my classes online, you won't have to go get the accommodation stuff or anything. I'm just allowing it. Otherwise, any of your other classes, I think if the teacher doesn't just allow you to do it online, you got to go to, I don't know, some department and get an accommodation or something for it. I'm not sure exactly how it works, but for me, it's just an email. And only if you need to be face-to-face. So you don't have this one less class to worry about. All right, so just like last semester, pretty much the same breakdown. Bible homework, 10%. Due every Sunday by midnight. All the assignments are up. This semester, we're looking at the book of Acts. So each week you read 2 chapters, you write a couple of sentences, you get a free A. Do it on time, get your free points, and get used to reading the Bible every week. All right, so I know not all of you are Christian or Lutheran, but it is a Christian school, and this is how we're going to incorporate a Christian worldview into the classroom. So you don't have to love it, but it's part of your assignment. So I'm giving you a free 10% to just get into the habit of reading the Bible every week. All right, so don't miss those. Set an alarm, do whatever to make sure you spend 10 minutes every week just doing this. All right, questions about the Bible homework? All right, all of them are already up. So if you don't trust yourself, you could just knock them all out right at the beginning of the semester. That's kind of defeats the purpose of being in a habit of reading every week. But if that's what works best for you, you can certainly do that. All the drop boxes are already open. Assignments will be 50%. So that'll be programming assignments just like last semester. Then we have two exams, a midterm and a final. Same rule as last semester. If you do better in the final than you did in your midterm, I'll replace the midterm exam grade with whatever you got in your final. So again, you have every opportunity to succeed. Because again, computer programming is like a sport. Got to put in the reps, got to put in the practice, and some of you are things are going to click at different points in time for you. So, I'm not going to penalize you for effort on the assignments. Remember, you have the self-assessment, just like we had last semester. So if you spend a whole bunch of time on an assignment and you have almost nothing to show for it, tell me about it so I can make sure I give you credit for your efforts, not just for your final product. Because again, this is like practice for the big game, and I want to make sure that you're being rewarded for putting in that effort, because eventually it's going to pay off for finally having the things start to click. All right, so assignments, make sure you do them, get them done on time, do them to the best of your ability, work hard on them, and you'll probably get grades on them better than you probably deserve based on what you actually submitted. All right, so again, just play the game, because all of these things that you're doing for these assignments are in preparation for these exams. So I encourage you to work in groups on the assignments. There were several different groups that met last semester, and that seemed to help the students quite a bit. Go on to Slack and put a message in the Slack channel if you are interested in getting together in a study group, and hopefully 2 or 3 groups kind of just naturally form. You can meet online in a Zoom channel, or you can, meet, on campus somewhere following the social distance guideline stuff. But, in any case, I encourage you to work together on the homework assignments. I'm not going to be looking that you turned in the same code because, again, it's practice. I'm going to find out on the exams whether you're learning this stuff or you're using your classmates as too much of a crutch. All right? And then you'll find out on the midterm as well. So then hopefully you can fix it before the final. All right, questions about grading and stuff? Okie dokie. No required book for the semester. We'll be using the Java documentation quite a bit. And then things that I will cover in class. All right, so you don't have to spend anything for resources for the class. Okay, so that kind of gets us through all the formality stuff thingies. So any questions about any of that stuff before we just sort of dive in?
I have one. How should we signify that we have a question? Should we use the raise hand option in Zoom, or just blur it out whenever it's there's a pause?
I would say just unmute yourself and scream.
Alrighty.
You could try the raise hand. I'm probably going to miss it. So just I think we can be you're not going to offend me is what I'm saying. So if you have a question, just interrupt me and say, hey, I have a question about that or whatever. It'll just be fine.
So is the Eclipse installer supposed to be like extremely slow when it does everything?
Potentially.
Yeah. Okay.
It could also be that your computer is doing multiple things at once, because right now it's doing the Zoom classroom, and if you're trying to install something, it's running that as well. So it's
Yeah, I mean, it could be that, but I've done other installs before during Zoom.
Yeah, it might be a little bit on the slow side. That's
It's
why
saying slow downloads, I guess.
but it's not a big deal for today.
I don't know.
It's cooking. Just you won't need it yet. It's fine. Just have it cooking for a little bit, and we'll get there. Okay, so let me just put a little reminder slide in here. So we have I probably have it somewhere in here. They're having us have more prepared slides for this semester since we have online and stuff like that. So it's a little bit against my style, but let's see what happens. How humans solve problems. It should be something all of you remember from the 200 class, right? We use our memory, ask questions, repetition, and all of our programming languages will have facilities for memory through something called variables. We'll have facility for asking questions through conditionals, and we'll have facility for repetition through functions and loops, that kind of stuff. All right, so 100% of programming languages will have facilities for these things. And if you remember back to 200, something we said in there is that the skill set is computer programming, not the language. Okay, so last semester we focused on Python as our example programming language that we were working with for when we were learning about programming concepts and object-oriented programming and things like that. In here, we're going to be using Java as our programming language. In 300, next semester, we'll be using C++ as our programming language. In software engineering, you'll be using C# from the .NET library as your programming language. When you get into 450 systems programming, we write an operating system and we use C as the programming language. When you get into 470, we write a programming language. You'll be using Scheme as the programming language you use to write the programming language. So the idea is that you keep bouncing between programming languages in an ultimate effort to convince yourself that, oh, once I know how to program, learning these languages is just a couple of day process of kind of seeing the little nuances, the syntax differences, that kind of stuff. It's not a whole new thought process on programming. All right, makes some sense? Okay, so throughout your 4 years, we're going to keep coming back to this idea of a slide where how do human beings solve problems? What's the job of a programming language? Its job is to allow us to tell a computer what to do while allowing us to solve problems the way that we are already accustomed to solving problems.
I have a question.
Sure.
So you said that it's usually going to be like a couple day process for learning a new language. Would you say that this first switch from Python to like a whole new thing, Java, as our first switch is going to be larger than that, or is it still just going to be a couple days?
It might be a little bit larger than that, and not because it's your first language you're switching between. If you remember from last semester, we had this idea of types of languages, and we had loosely typed versus strongly typed. We had interpreted versus compiled. Well, Python is loosely typed and interpreted. Java is strongly typed and compiled. So you're kind of seeing kind of maybe almost the other half of programming languages this semester. So there might be a little bit bigger ramp up, but not like substantially so. Like, you know, like an example here might be if I want to have a name in Python, I would say name is equal to Mike, right? In Java, I would say string name is equal to Mike. I have to define the type associated with this variable. You know, so it's little things like that. It's not just the straight, you know, there's like syntax differences, getting used to throwing semicolons at the end of each line, that kind of stuff. That's more of your normal, you know, Python has you do a colon and then you indent underneath it, where Java has you just end every statement with a semicolon. So that's just syntax, getting used to it. But, you know, making that little transition between, oh, well, I never had to put anything in front of my variable name before, but now I do. And here's why. It's a strongly typed language. So that initial transition might be a little bit longer with reason. But then now you'll have kind of both bases. So when you go on to, and it really, I mean, it's funny in an election year, everything follows party lines, right? If you're using any sort of loosely typed, interpreted kind of web kind of language, you know, they'll all kind of act like this. If you use any sort of native language that's used for writing iPhone or Android or Windows or Mac applications, they'll pretty much all look like this. So you'll kind of have both sides after this class. So when you go to learn C#, for example, C#, your Java programs will almost accidentally work in C#. You'll have to change, like instead of in C#, it's lowercase s for string. Name is equal to Mike. Yeah, I mean, it's like a couple like upper and lowercase things, and then instead of system.out.println, it's console.writeLine for printing stuff out. You know, most of it's pretty much the same jazz. So I wouldn't, you know, to your question, will this take longer? So, you know, I'm saying it's going to take just a couple of days, and we're going to spend the first couple of class periods kind of looking at, here's Python, here's the equivalent code in Java. So maybe instead of a couple of days, it'll take a week, something like that. I mean, you're going to still be kind of uncomfortable with it for a little bit to your use. You'll figure out which mistakes you make, but very quickly you're going to recognize stuff. It's not like you're looking at, you know, Greek or something like that. It's you'll pick up on it pretty quickly. Okay, but again, everything kind of falls off this idea of how human beings solve problems. That is the foundation in which a computer science education is built on. We are humans. We're so good at solving problems that we have trouble articulating how we solve them. Now, as budding computer scientists, we're starting to get a little bit better at articulating those things. We're also kind of understanding maybe where some of our limitations are. So for at the beginning of, hopefully you all recognize that from the beginning of last semester to this semester, we are better at articulating how to solve problems than we were. You know, we've gotten better at breaking problems down to like solutions into little tiny steps. But hopefully we also recognize that we're also limited on how complex the problems we can solve are, right? You know, because even if we go back to my example from the very first class or the first week of 200 with, you know, how many of you got to class today without bumping into any walls? Remember that, Jazz? And, you know, we can't even pay attention enough to walking to pay, you know, we're too busy texting and stuff like that. Yet walking is obviously an extremely complex task, right? And I don't think any of us, no matter how how much we've gotten experience programming, could ever fully articulate every little thing you have to do to walk, right? So therefore, it would be very difficult for us to write a computer program that actually solved that problem. So when you put that in the context of solving problems in the real world, we're looking at a problem like walking and we're saying, well, that's too complex, I can't articulate it. Yet at the same time, it's not worth our full attention to go for a walk because we can text on our phone while we're doing it. That's the chasm that exists between how good of problem solvers people are and what we can actually tell our computers what to do. All right, and this is almost kind of where the need for artificial intelligence is now. So with artificial intelligence, as some of you are going to start taking some of those classes, is anybody taking the machine learning class this semester? Is that this semester or is that next semester? Is that this semester?
I'm taking something, artificial intelligence, something like that.
AI something. Okay, well, regardless, the machine learning class is, I think, the cool one because that's more of applied. You write software for it, but the other one will talk about the same concept. Really what AI is this idea of a black box. So you're writing a computer program rather than solving a problem. You're writing a computer program that models our simplified version of the human brain, and then trying to train that model to solve problems somehow. All right. So what you end up having is it's like a decision engine. You're saying, should I turn left or should I turn right? You feed it into the neural network, and then it makes a decision. And sometimes it messes up, sometimes it doesn't. Then you try to make a better decision next time. But what you might end up with, let's just think about like our example of walking here, is maybe we can create a robot that's running off of a neural network that's been trained to walk. And we can't then look at the logic and say, oh, well, this is what walking means. Instead, it's just a whole bunch of little, signals firing, and ultimately it takes a step, then it takes another step, then it takes another step, and we have no idea why it works. It just does through patterns. We've trained it to do that, just like us, right? As we walk down the street, we're not thinking about all those muscles we're firing and stuff like that. So effectively, our own brain is like a black box, right? There's a whole bunch of problems that are just so complex, yet they're not very difficult for us, that we've just been doing our whole lives, and it just works. We do it. And it would be hard for us to explain it in any sort of great detail to somebody else. So I think that AI, if you kind of move away from the sci-fi aspect of, like Terminator and, all Transformers and all, well, I'm a big Transformers fan, so we don't want to move too far away from that. But, you start moving away from the sci-fi version of this and you start thinking about what problem you're actually solving. You're trying to bridge that chasm where a human being ends at where we can legitimately articulate how we solve problems. There are just some problems that we're just too good and the problems are too complex for us to ever reasonably be able to articulate the steps. So that's where the line's going to be at for using a computer programming language to solve that problem, right? If we can't, even through lots of practice, articulate the steps to solve the problem, we're never going to be able to use a programming language to write those steps if we can't come up with them to begin with. That makes some sense? So AI is kind of the hop across that chasm and says, okay, well, we really can't figure out how to write it. So we're just going to create this model that hopefully we can train it to just do it. And it's kind of cool. That's the AI kind of coolness thing. But it really is a different way of processing computer science, processing problem solving. You're creating a model, then training the model rather than writing the logic. So kind of a cool, fascinating thing, I think. But, the important thing for us in here is hopefully we do see that, we will have limitations for the types of problems we can solve with computer programming. We have to be able to fully articulate the solution to a problem in order to write software that mimics that solution using Java or Python or C#, pick your poison, right? If we can't articulate the steps, we can't then convert them into the syntax for that language. All right, so right off the bat, human beings wake up every single day and we solve significantly harder problems than any problem that a programming language has ever used to solve. even though some programming languages, they just make life very convenient. Programming solutions make life so convenient for us that we like to put them up on some pedestal, like they're solving some astronomical problem, when really they're just automating a bunch of stuff that makes our lives easier. All right. But again, our foundation here is this: we're human beings. How do we solve problems? The programming language gives us a tool for translating this into something the computer can understand. All right, questions about any of that? All right. So let's look at a couple of examples here. So I'll actually take it out of here. What do I have on here? Do I have Adam? I know you can't see Adam yet, but I'll promise I'll get you over there in a moment. All right, you can see the screen there. How's that text size? Is that good? All right, so we'll paste some text in here. I'm going to go ahead and save this file as CSC200 Python test.py. All right, so there is a working Python program that, that should look fairly similar to you from like the last 25% of last semester, where we were trying to start talking about those scoping rules, like where we have access to variables. So we created a function called main. I had this saying that all programs begin and end from main. Remember that guy? All right, so then, so here's my main function. We have our little colon there, then we indent underneath it, print hello world, blah, blah, blah. And then when the program starts, if the name of it is main, we just call that main function, and this gets us our hello world. And if I go ahead and let me actually share this might be better. I just share my desktop. Is that just as good, do you think? You see it fine? All right. So what I might do now, if I open up a terminal, if I want to run that program, Python 3, CSC 200, Python test py. Oh, copy and paste. Sometimes you copy and paste double quotes from some things. It gives you the wrong version of the double quote. I copied it out of the slides. So there we go. Now we have the right version of the double quote. So there's our running hello world program. Cool? All right, so that's nothing new for us. We've seen that before. So now we want to see what's the Java equivalent to this. So I'll go ahead and I'll create another new file in here. Go ahead and save this, CSC200, Java test.java. All right, so our source code files, instead of being .py files, they're .java files. Okay. All right, and what I'm going to have is I'm going to have a public class. I usually call the class driver. We'll come back to why that is later, but this is just some class name. And you're familiar with the class keyword. What's the class keyword used for? When we were exposed to that in Python, what is it used for? You got nothing?
If I remember from what feels like decades ago, I think it was objects.
It is objects. Feels like decades ago. Nothing major happened over the summer.
So
Sure, nothing.
It's like a major understatement, right?
So why did we put public in front of that?
Don't worry about that yet.
Okay.
Just let me throw it there for now, and then well, here, I'll answer real quick, but then I don't want to go too far into it. All programs begin and end with main. We're about to write the main method in here, and in Java, the class that has main must be public in order for the Java virtual machine to run it. That's kind of like the rule. We'll talk about what public, private, protected means as we get into the semester. They're the security keywords. For right now,
Okay.
everything should be kind of public for us, right?
Is there like stuff like that in Python too?
They technically do exist in Python, but because Python object-orientedness is kind of an add-on, it's a little bit more cryptic, where Java was object-oriented from day one, which is why even our main method is embedded inside of an object, embedded inside of a class. All right, so we'll go ahead and write our public static void main string array args. So this is our main method. Don't worry about static and stuff like that. We'll talk about all those things. So
I shouldn't just ask you about what everything means?
Right, yeah. I mean, basically the goal we're trying to get right here is just to see the similarity between Python and Java. All right, pretty quickly things will just start looking very normal. All right, and then we're going to print something out, system.out.println, hello world. All right, so this is a Java program. So we have a class, and embedded inside of this class, we have a function, and that function happens to be called main. And what does this guy do? He prints out hello world. So just to show you this in action, I'll just come out here. And because, if we remember back from our slides before, let me pop this up, I mentioned that we have loosely typed versus strongly typed language. So Python is loosely typed, Java is strongly typed. We also have interpreted versus compiled. What is the difference between an interpreted language and a compiled language? Also from 200.
Interpreted, you like the code is brought from like higher level code to like machine level code, like as you're going, but compiled, it's like a process. Like when you run the code, you have to wait for it to compile, and then it's transferred to machine level code.
Yep. So really, it's a single step versus a two-step process. So interpreted, we just make the transition on the fly between what the human wrote and what the computer understands. Whereas compiled, we have to do the translation before we run it, and then we run it. So we have to compile it first. All right, so I'm about to do that step here because Java is well, here, let's actually just give a little definition here. Our languages. Python is a loosely typed interpreted language. Java is a strongly typed compiled language. Okay. I'm actually going to take this one little step further before I show us our punchline here. Remind me, what's a virtual machine? We all used one last semester, right? So if you had to define what a virtual machine is, what would you say that is?
You like take part of your computer and like use that part of the computer to run a different version of an operating, or a different operating system, or a different version of an operating system.
Emulation.
So would you say that a virtual machine is a piece of software that pretends to be a computer?
Yeah.
So you ran VirtualBox last semester, right? So that was a piece of software that pretended to be an Intel-based computer, right? That you can then install Linux on, just like you were installing it onto your laptop or something like that. But it pretended to be a computer, and it was a computer written in software. We have something called the Java virtual machine. And this is a piece of software that pretends to be a computer that knows how to run compiled Java code. And if we want to think about what that means, so we could say Java claim to fame. Java is platform independent. Anybody know what that means?
Can it run on like any device?
Yeah, so one of the problems we ran into years ago with other compiled languages, and I'm not sure it was as big of a problem as the Apple people made it out to be at the time. But if we just want to keep it in the, give us a real life example. So when, you had some video games that would have come out, and they would originally come out for Windows instead of Mac, as you might imagine, because everybody ran Windows, right? You had 98.25% of the population running Windows, and you had, at max 1.5% of people running Mac, and well, they should be treated fairly, or they can just buy a Windows machine, either one. But in any case, the idea is a lot of those video games are written in a language like C++, which is a strongly typed and a compiled language, just like Java is. But the problem is when you use a compiler, let's think about a compiler here for a second. A compiler requires two things. Okay, it needs to know the target architecture, which is a fancy way of saying what kind of CPU will this code be running on. It also needs to know about the target operating system. What kind of OS will this code be running on? If you remember back earlier last semester, let me pop this back open. Hello World Linux Assembly, remember that guy? We were first talking about how CPUs work. You kind of remember us looking at this early on last semester? Like, how does hello world look in a low-level language like assembly, where it has a one-to-one relationship with the CPU? And remember, kind of that go-to move is, we moved a whole bunch of values into some memory locations in the processor. All right, and we'll talk about stuff like this when you get into like the 325 class next semester, and actually dealing with computer architecture and organization. So I don't want to get too deep into the nuts and bolts here, but effectively the way the operating system works is, or the way the assembly language works is, it says, okay, we're going to move some values in here, and then we're going to call upon the operating system and say, do your magic. And what happens is the operating system goes and looks in this memory location first and says, you want to do magic trick number 4. That's called syswrite. Well, I need 3 pieces of information for that. Where am I writing it? What am I writing? How long is it? It was the operating system that dictated that that's what these lines of code looks like. And remember, a compiler translates from a high-level language like Java, like C++, into a low-level language like assembly. So if I had written my video game in C++ or C, and then I compiled it, it not only needed to know that I was compiling for an Intel processor, so it made sure it used the right languages here. It also needed to know that I was doing this for, in this case, this is Linux, the Linux operating system, but it also had to know what operating system I was targeting, because it would create this low-level Intel-based assembly code with the operating system in mind, so that it would create the correct equivalent logic to what I wrote in my high-level code. Make sense? So that means if I wrote my video game in C++ and then I compiled it for Intel Windows, that would not just work on Intel-based Mac. Because even though they're the same processor, they're not the same operating system. I would have to recompile it and possibly make some changes in case the Mac handled things differently. But even older than that, when we went back to the time where people were really complaining about this stuff, Mac was no longer wasn't running Intel processors yet. So if you had a Macintosh computer, you had something running the Mac OS on top of the PowerPC processor versus something running Windows on top of the Intel processor. You know, these aren't the same pieces of equipment, even though they're both computers. So as you can imagine, compiling that C++ code for a different processor and a different operating system was likely going to require some extra heavy lifting by the programmer, probably rewriting large percentages of the application to work on the second computer. Kind of make sense? So at that point in time, when Sun Microsystems was coming out with Java, they were trying to solve a problem that I would say in hindsight wasn't a problem that necessarily really needed to be solved. But it ended up working out because now we have a lot of applications that kind of launch out of websites running Java that have given us kind of full-blown applications that run out of Java. The best example I can probably give you just on the fly is sites on like real-time trading platforms for the stock market, where they have these applications that allow you to do like day trading that launch completely out of a web browser, and those are written in Java. Because Java, where did I write it, is platform independent. What does that ultimately mean? It means the Java people, this was Sun Microsystems, now Oracle bought them years ago, or acquired them years ago, I guess, wrote a virtual machine that runs on Windows, Mac, Linux, etc. That VM knows how to run compiled Java programs. Even though this virtual machine might be slightly different on Windows, on Linux, on Mac, they only had to write that application. Think of the virtual machine like the video game. They had to write the video game 3, 4, 5, 6 times. But once they did that, they now have Java-based computers that run on every other normal computer that can run any Java program. So you can write your Java program once, compile it once, and it will run on any computer that has the Java virtual machine. Now, you do give up a little bit of performance there because you are having to do some sort of translation in the middle. That virtual machine is having to do some extra magic. But still, what you have is now programmers can write software once and target a much broader audience. With the cost being speed, but as we talked about last semester, most computer programs are not going to push your processor to its limits. Therefore, a very high percentage of computer programs, we're not going to notice it's any slower. We ran Python last semester, and Python's completely interpreted, and everything felt fast enough, right? Same thing's going to be true with Java. Java should actually be even a little faster. But where's Java going to come up short? Well, you're probably not going to see the next Call of Duty written in Java. Reason being is those are, high intensity video games that are trying to maximize memory usage, CPU usage, all those things. So you don't want to add any sort of slowdown in the middle. But a whole lot of applications like, Angry Birds could be written in Java, something like that where, you're not really pushing your Core i7 quad core processor with Angry Birds. Everything's going to be just fine. So Java really does solve a good problem. It maybe just doesn't actually solve the problem they were initially pushed to solve, which is kind of, I think, maybe a little bit fascinating. All right, but in any case, we dealt with virtual machines last semester in that we installed a piece of software on the computer, VirtualBox, that was a piece of software that knew how to run pieces of software that run on Intel-based hardware. So really, it knew how to run operating systems for Intel-based hardware. This virtual machine is a piece of software we install on our computer that knows how to run Java-based software. Make sense? All right, so getting back to our example here. So I've written this Java program. So now what I have to do, since Java is a strongly typed compiled language, before I can run it, I have to compile it. So I'm going to use the Java compiler called JAVAC. Now, you won't have to do this because Python or Eclipse will do it all for you. You're just going to hit a little play button and all of it will happen. I just want you to see the process, what's actually happening behind the scenes. So I'm going to use the Java compiler, which I already have installed on my computer here. And what did I call it? CSC250 Java test. So I'm going to, actually, let me just do something here real quick before I, no, I'll just do it. Oh, sorry. That is my fault. I was too busy telling you that I like to name the class driver. I should have named this class the file driver.java because of that. Java requires that your class name matches the name of the file. Those two things have to be the same. So I'll just update the class name to be the same thing I named my file. All right, so let me just show you something here real quick. CSC200 J*. So if I show you my directory listing of that file, right now I see I have CSC200 Java test.java. If I go to compile this file now, nothing pops out. It's not upset about anything. Who knows if my program does what it was supposed to do, but at the very least, it's syntactically accurate. Now, if I run this again, this ls, notice that I now have a new file called something.class. And what this is it's the assembly code. It's the what's called Java bytecode that knows how to run on the, well, that the Java virtual machine knows how to run. Okay? So if I were to look at that, this is crazy looking stuff. All right, it's Java bytecode. But now, if I want to run this program, I tell Java, this is the Java virtual machine. I say, Java, run this compiled Java file. You don't put .class on the end of it, you just tell it the file to run. Press enter, and there's my hello world. So with a compiled language, there's a two-step process. Take your source code, you compile it to Java bytecode, which then gets run on the virtual machine. So if we actually drew the picture for what's going on there with Java, we have Java source. Oops. Which gets compiled into Java bytecode, which then gets, I'm actually going to throw a new word in here. I'm going to say interpreted by the Java virtual machine. Actually, let me write it like this. We'll say sent to the Java virtual machine, which then gets converted to assembly. And ultimately executed on the CPU. So that's what's actually happening. We write our Java program, we compile it. It turns into that .class file, the Java bytecode. We then send that to the Java virtual machine. So when I typed in Java space, the name of the class file, that was the Java virtual machine executing that. What it actually does is it converts it into native assembly code for, in this case, I'm running Mac OS on an Intel processor, which then gets executed on the actual CPU. Okay? But if I took this exact same Java source code file, actually, if I took this exact same Java bytecode file, something I've already compiled, if I took it over to a Windows machine and I ran it on the Windows Java virtual machine, it would convert it to Windows-based assembly, which would then execute on the CPU in that Windows machine. All because Sun Microsystems wrote the Java virtual machine for a bunch of different operating systems. So they took the porting of the code over to the operating system level, not into the programmer's level when we write our code. We can write our code once, and we can run it anywhere that supports the Java virtual machine. That make sense? So it's kind of a feature of Java, let's say. Okay, but from the programmer's perspective, if we are going to write our code, then run our code, we have to, whenever we make a change, we have to recompile it using the Java compiler, and then we can run it here. So if I want to change this to Woot World, and then come back out here, and I just rerun the previously compiled file, you'll see it's still Hello World. But if I recompile that file, updating the Java bytecode, and then I run it, notice I get Woot World. All right, so with a compiled language, this is a two-step process. We have to take our source code, we compile it, which translates it into low-level code that runs on that machine, and then we can execute it. With an interpreted language like Python, we use the Python interpreter to run it in real time. All right, questions about that?
When using Eclipse, will we have to manually compile our code every time we want to run it, or will it automatically do that when you hit a run button?
Yep, let's jump over to Eclipse here, and I will show you. Actually, let me kill this Eclipse because I'll use the other one that we had. All right, so I'm going to go ahead and just create a new Java project here in Eclipse. And here, I'll make my project, well, here, we're going to call it CSC250 Java test. There, we'll just keep it very interesting, right? So we'll use the default location, which was in my Dropbox. We'll use an execution environment, the JRE, so that makes it automatically able to run just right here inside of Eclipse. So just don't touch that. It asks you which Java virtual machine do you want. So, you know, I have a whole bunch of them here installed on my computer from just a long time of doing these things. I'll just leave it on its default. The default here is create separate folders for sources and class files. I'm going to leave it like that, even though I actually prefer this top one. And we'll talk about that when we do file IO later on, but we'll just leave it. Just don't touch any of this stuff. Just hit finish. And what that'll do, and so there's my module name. So I'll just go ahead and hit create. And let's see, can I make this bigger? The bad thing is making it bigger there is more for me than for you. All right, so here's my, don't worry about that module thing. That's kind of a new Java thing. You can actually take it out if you want. I'll just leave it in there. I'm gonna say public class, actually, hold on, I'm sorry. I'm not gonna touch this stuff. I'm going to come over here to source. So over here on the left, we got this module thing. So just leave this, don't worry about that. But it's this source folder where I'm going to put my code. I'm going to right click on source. I'm going to say I want a new Java class. And I'm going to call this guy driver like I wanted to do earlier. I'll just hit finish. So there's my class driver. I'll just put in here public static void main string array args system.out.println hello world, like that. And then I'll come up here and hit the play button. The very first time it'll say select the resources to save, blah, 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 since I didn't hit save. So I'm just gonna hit this little checkbox that says always save resources before launching. Errors exist. What are you upset about? I have to declare the name of my package for this? That's the whole module crap. So there's my hello world. So I didn't have to compile it and stuff first. I just had to hit this little play button. And if you missed it here, I just deleted that module file. They want you to use something called namespaces now. And then, well, it's namespaces in C#. So Eclipse does it in something called a module, which means that you can't use this thing called the default package. Eventually, we'll talk about packages to keep your code separate. But right now, we're just keeping everything simple. So just delete that module file and everything will just work as I'm using as examples.
So for, like, what's the difference between this and something like Visual Studio?
Same. Eclipse, as we're using it, Eclipse is Visual Studio for Java. Visual Studio is Eclipse for C#. Even though they both support other languages other than Java and C#.
Okay.
But they're both IDEs, integrated development environments. So this is the same thing as Visual Studio, which is the same thing as Xcode on the Mac, which is the sort of kind of the same thing as Thonny on Raspbian, although Thonny was substantially less featured than any of these applications, but all the same kind of tool. All right, so for us, when we're writing our Java code, once we make a change, so if I want to change this to Woot Hello World, and I just go and hit play again, and there's my Woot world. All right, so, but now we appreciate what's actually happening behind the scenes, because what did it do? It actually compiled it for me and then ran it for me. Make sense? All right, so I have that in the slides here for your Java program template. You can kind of see how old Python programs looked, and then here's the equivalent in Java. Notice I mentioned in here you have to say, put it in a file called driver.java there. All right, so this talks about the different things we're going to be doing in this class. So we're going to be initially in our the first several class periods looking at how do we do all of the things we learned how to do in Python, how do we do those same things in Java. So that'll go pretty quickly, but we'll be looking at the nuances, the differences between them, okay? Then we're gonna have a section where we look at a bunch of different searching and sorting algorithms. So we'll look at a linear search, selection sort, bubble sort, insertion sort, binary search, recursion, and merge sort. Then we get into object-oriented concepts, but we already learned object-oriented stuff from 200, but now we'll be taking that a step further and going into kind of like second tier object-oriented stuff, working with abstract classes and interfaces, more inheritance stuff. And then we'll build simple user interfaces with either Android or Java Swing once we get there. Okay, so in the slides already, I already kind of took you through it, but here's a video for installing Eclipse on your computer. So get Eclipse installed on your computer. Secondarily, we're also going to be using a tool in here called Git, a tool called Git, and through a website called GitHub. So if you don't already have it, if you go to github.com, and that video takes you through that. Not GitHub, although that should exist. It should be something. I'm going to buy that domain. All right, github.com. That takes you here, and create an account if you don't already have one. I sign in. This is how you're going to be submitting your homework assignments. Maybe not right at the beginning, but pretty quickly. Actually, did we use GitHub last semester? Never used it.
I don't think so.
Yeah. Well, you would remember it. All right. So the idea is that last semester, towards the end, our programs started getting longer and longer and longer. Pretty quickly with Java, our programs are going to bridge multiple files with object-oriented stuff. So the easiest way, so instead of you having to copy and paste code into a single document, we're going to have you check your code into GitHub using the tool called Git. And then you can share the link with me where I can view your code, is going to be the idea. Again, this is an industry standard tool for what's called source code management. So this is something that when you go out and work in internships and stuff like that, they're either going to expect you to already be familiar with GitHub specifically, or at least be familiar with source control for keeping your files uploaded and up to date. So when I make a change to some code, like when I solve problems in class, I'll upload it to GitHub at the end, so you have a link to the solution to that assignment, that type of thing. All right, so right here, this is on slide 17. Get your Eclipse environment set up. Do that as soon as possible, and get your GitHub set up. So get an account, and then you'll also get the Git desktop application. There's other ways of using GitHub other than the Git desktop application, but that's probably the path of least resistance for everybody right now. So if you want to challenge yourself and look for other ways of doing it, even from the command line, you can, but we're going to be using the desktop application in here as our example, so I don't have to manage 20 different ways people interface with GitHub. GitHub is an industry standard tool, very, very popular. And then here's a Wikipedia page for the Java programming language. We're going to be covering all that, but feel free to peruse. All right, everybody's already on Slack. Okay, so that gets us up here to start looking at the CSC200 refresh. But maybe for next class, work on getting your Eclipse set up and getting your Git and GitHub accounts and tool downloaded. Questions, comments, concerns, bribes?
You said we're going to go through like next class and just do a little refresher on 200.
Well, yeah, we're going to do more than just a little refresher, but yes.
Has the CS department scheduled any tech talks for this semester, or is that not going to be a thing?
It's going to be a thing, probably through Zoom. Well, definitely through Zoom. We have 2 people we're waiting to hear back from, so we will have at least a couple. So stay tuned for that. If I don't have, ask me again by the end of next week if I don't have dates set.
Also, if you're interested in being in Hackathon Club, like go ahead and put that on Slack. We're looking for people to join. It's a good way to like practice programming and everything.
And one last thing, if you do want to be in person and that's your preferred way of learning, if you don't care, don't email me, but if you really do care, you definitely want to be in person, send me an email so I can get you on the list to make sure that we can accommodate everybody who feels they will learn better or perform better or whatever in person. Okay, and get that to me as soon as possible today. Sound good? All right, I will see everybody on Thursday.